Wow, I love it. Thank you so much. And the other travels west at 24 miles per hour.
You too.
Good. At what rate in miles per hour is the distance between the cars increasing 4 hours later? So dw over dt when t equals 4 hours. So this is our question. How fast is w changing when time is 4 hours? And of course we cannot use 4 hours. As we know, that is a trap. We cannot use 4 hours because if we did and we differentiate, we'll get always 0. So remember, that is the key. Okay, so we have a right triangle. I'm going to denote this by x and this by y. And I know the Pythagorean theorem. The sum of the legs squared equals the hypotenuse squared. So please understand, do not say a squared plus b squared equals c squared. It doesn't mean anything. Because you're not telling me, unless everyone knows and it's a law forever, that a is a leg, b is a leg, and c is a hypotenuse. If this is a law forever, then you can say that. But if you change the notation, this is incorrect. So that's why I teach my students to always say the sum of the legs, each leg squared, equals the hypotenuse squared. So now we can differentiate both sides. They're all functions of time. So we can put a dot underneath them so you don't forget. So when we differentiate the left-hand side, we must differentiate the left-hand side, right, left and right. So we have 2x dx over dt, because x is a function. That's why, in order not to forget, put a dot underneath. All these are functions of time. Plus 2y dy over dt equals 2w dw over dt. And we're after dw over dt. Of course, I'll simplify both sides by 2. And when I solve for dw over dt, I would get all this over w. So x dx over dt plus y dy over dt. Now, I have everything I need. So my next step is simply plug it in. So now I can say when t equals 4. And when t equals 4, first of all, dx over dt does not change. That is 24. dy over dt does not change. That is 32. And now, in order to find this distance, I have to multiply. So distance equals rate times time. Time is 4 hours. And for x, the rate is 24. But for y, the rate is 32. So x and y will be determined as 24 times 4. And for y, 32 times 4. So this is our x, and this is our y. Now, what do we do with this? No problem. I have it here. So w is the square root of x squared plus y squared. And I will have these when I multiply these two. Is that clear? Any questions before we finish it up? So x is 24 times 4, but then we still have to multiply that by 24 because that's what
yes,
dx
because when we differentiate, that's what we have. When we
so
differentiate,
we it and then times 4. Okay.
When we differentiate the function squared, we write 2 times the function prime. That's by the chain rule.
Oh, right.
We have no choice. We have to use the chain rule. So therefore, I would have all the numbers in here will be these.
So x, 24 times 4. Lazy people use a calculator. 96. Multiplied by 24 plus 32 times 4. I shouldn't do this, but I'm not giving you a good example. Okay, so then I have x squared, which is 96 squared, plus y, which is 128 squared. Okay, so then when I put the whole thing in at once in the calculator, please remember that you have to put parentheses around the numerator. I will also put parentheses around any quantity under the square root, but it's not necessary in all calculators. So I'm going to switch to the other one so it's easier to show. So parentheses 96 times 24, and then plus 128 times 32, and close, and divide by the square root. In most calculators, it pops up with a parenthesis, not in this one anymore, the sophisticated ones, plus 128. But I don't know what calculator you have, and I'm just too used to putting parentheses everywhere they are needed. So it's 40. And what is the measurement unit? Because 40 is not enough.
Miles per hour.
Of course. It's the rate of change of distance with respect to time. dw over dt, miles per hour. Very good. Good. Next question. Anything from anything? Chapters 2, 3, 4, 5. Any topic, please.
Can we go over, I don't have a specific example, I can find one. Like doing the absolute, like max and minimum, like the local and relative max and minimum.
Yes. You want on a closed interval?
Yeah.
Okay. Those are in chapter 4.
I have WebAssign open if you want me to pull something up.
Yes. Absolutely. So max min on a closed interval are in 4.1.
Mm-hmm.
We can choose any problem you want.
Well, this asks for critical numbers, but
We have to have critical numbers. I mean, we have to determine them, but
find a
it's
critical
further down the road with absolute max, absolute min.
number. Fine. Okay. Okay. F of x equals x plus 9 divided by x on the interval 0.2 to 12.
Perfect. Good. Okay, so first of all, I start with the interval, 0.2 and 12. I have f prime of x and f of x.
Oh, it's also not, because did you extend all the assignments to the end?
Yes.
Because this one's not extended, 4.1.
Oh.
Because it lets me, it shows me I got the minimum correct, but I got the maximum wrong, but it doesn't allow me to change it. It says it's past due.
Oh.
And it wasn't, this section wasn't showing up in current assignments. I had to click all assignments to get all of chapter 4. So I think chapter 4 didn't get extended.
Okay, it will be selected and extended right now. As you know, it's really crazy. I try one thing and then the other side is not. Okay, let me know now.
You see, I probably have to refresh.
Yes.
Yep.
Perfect. Okay, so this is the problem, right?
9 over x. Yes.
Perfect. So first of all, we have to find f prime. And please remember, this is 1 minus 9 over x squared. Please remember that 9 over x is 9 times 1 over x. And please remember that 1 over x prime is negative 1 over x squared. This is a basic formula that you should not have to prove again and again and again. So this is x squared minus 9 over x squared. Critical numbers are, of course, x equals 3, x equals negative 3, and x equals 0. But x equals 0 is not in the domain. X equals negative 3 is not in the domain. Okay? So the only one is 3. I have to study the sign left and right. So when I plug in 0.2, for example, this will be negative. When I plug in 12, this will be positive. At this point, I have to determine these numbers. So I have to plug in 0.2 in the function, 3 in the function, and 12 in the function. And of course, they have to work like this because of the sign of the derivative. If they don't, something is wrong. We go back to the drawing board. So in y equals, I will plug in, first delete whatever, and let me change this into off. Okay. So x plus 9 over x. So what I need to do now is just plug in, again, 0.2, 3, and 12. And I copy 45.2. I copy 6 and 12.75. And now I have to draw a conclusion. This is definitely the relative and absolute minimum. Relative, absolute, min. Obviously, this is the largest number everywhere. So this is the absolute. It cannot be relative. It's at the end point of the interval. And this is nothing. Why is it nothing? It's because it cannot be relative at the end point of the interval. And it cannot be absolute minimum because there is one smaller than it. It cannot be absolute maximum because there is one larger than it. So 12, 12.75 is nothing. 3, 6 is the relative and absolute minimum. And 0.2, 45.2 is only the absolute max. It cannot be relative at the end point of the interval. Good. Next topic.
So what about the, oh, I'm sorry. Did you want to go first?
No.
No, I was just saying good.
Oh, so I know on test 3, there was some questions where we then had to go back and graph it. Is it possible to graph this one, or can we do another example? We have to graph it as well.
So the graph, first of all, does not give us a domain.
Okay.
So the graph is find the domain, find the range after you graph it, yada, yada, yada. Find points of inflection, concavity, max, min, inflection points, asymptotes.
Is that something that we need to focus on, like graphing?
Absolutely. Absolutely. It's
okay.
A major application of differentiation. Major.
Okay.
So graphing is in 4.5.
These are also recorded too. I know we're doing a review for the final, but these are also recorded as well.
I recorded all 15 weeks, everything I said, everything I wrote, and they're always posted right after class.
No, I mean like tonight's review session as well.
Everything is recorded. Everything I say, everything I do in all my classes. Yes.
Okay.
Everything. For the help of the student, I will always do it. I've been doing it for 15 years or more. I know that if I had this when I was a student, I would have been super happy to be able to go back and redo each problem.
I wish all teachers did that. I'm trying to open up web assignments.
Yes.
To go to
Yes, I can open for you and you can choose.
Okay, that would be great.
Oh yeah, of course. So where is the book? Right here. And that's 4.5. It's a summary of curve sketching and includes everything, including slant asymptotes.
Can we do 16? Actually, no. Can we do 17?
Yes, 17. Very good. So in 17. So y equals x minus 1 over x squared. Perfect. So we're asked to show everything. So for this function, first of all, I would immediately realize that when x equals 1, y equals 0. So this fraction is 0 only when the top is 0. I will also know that x cannot be 0 because this will be a vertical asymptote. And I will also immediately determine limits. But because I need to determine the horizontal asymptote if there is one. So the limit as x approaches infinity or negative infinity is not going to make any difference. Of x minus 1 over x squared, we can lose L'Hopital's rule. It's infinity over infinity. So then we have limit as x approaches infinity from 1 over 2x. But we don't even need to, because we know that when the degree of the top is smaller than the degree of the denominator, the answer, or the horizontal asymptote, is always 0. Like here, 1 divided by infinity, 0. So I already determined, by simply looking at this, okay? By simply looking at the function, I determined the x-intercept. There is no y-intercept because I cannot plug in 0. At x equals 0, the function has a vertical asymptote. I also determined the limit at infinity, or negative infinity is not going to make any difference, to be 0. So I have the horizontal asymptote by simply looking at the function. Now I will start my table. And I will do something else before I start the table, but I just want to write it first. So negative infinity, 0 to infinity, 0, 0, y equals 0 horizontal asymptote. At x equals 1, the function is 0. And now the limits left and right. Right here. And then I will start with the first derivative and then second derivative. So the limit from the left. So limit as x approaches 0 from the left, from x minus 1 over x squared. I know it has to be infinity, and the other one as well. I know it has to be infinity, but I don't know the sign. And that is what I'm after. So 0 from the left, like negative 0.1, this is positive, but this is negative. 0 from the right, like 0.1, this is positive, and this is still negative. So both of them are negative infinity. I exhausted the function. The function is done. There is nothing else I can find other than symmetry. But a function that has a x-intercepted 1, 0, and not here, it cannot be symmetric. So you can say that f of negative x does not equal f of x, and it does not equal negative f of x. Guaranteed. Not symmetric.